Are we on? Okay. I can hear it now. Good. It's stretched. So who's a new Star Trek attendee? Wow. This is the first time I've spoken here. I got to come here last year as a vendor representative for the Internet Explorer team, which was kind of fun. I really thought the conference ran really well, so I had to come back. So who's really here just for the movie tonight? If y'all let me, I'm going to go ahead and get started a couple minutes early because this is about a 90-minute presentation that I normally do in 75 minutes, and I added more slides for today, and we got 60. So this is going to have to move pretty quick, I think. So I was talking to the moderator beforehand. I don't normally get to speak in the Midwest. This, I think, is the second or third time in the Midwest that I've been able to do a presentation. So this is a kind of a big deal to me. For those of you who don't know me, I'm Chris Love. I currently live outside of Philadelphia, but I'm from the South, primarily Raleigh and Dallas-Fort Worth. So I'm a little outsider in the Northeast right now. You can follow me on Twitter at Chris Love, and my blog is Love to Dev. And I do write a lot about web development, especially what I call modern web development now. I tend to specialize in single-page applications. And one of the things that I spend a lot of time on is web performance optimization, research, and practical applications. And that's what I want to talk to you about today, because it's one of my favorite topics, is making the web go really fast. Now, I've got kind of a special Star Trek edition of it. I was hanging out with some of the other speakers this morning, taking fan photos. This is one of them right here. All right. Okay. A little more about me. I've been an MVP for, I think, 8 years now. I'm also an insider, which gives me a lot of dialogue with the ASP.NET team. Over the last 2.5, 3 years, I've been an Internet Explorer user agent. Recently, we've been joking that we're now Spartans, and I guess as of a couple of days ago, we're now E user agents. We aren't really sure what to call ourselves right now. Anyway, so I get a lot of dialogue with the Internet Explorer team as well, which has been fantastic as somebody who I tell people I live above the API, I really live inside the browser. So having a dialogue with the guys who write one of the browsers has been so beneficial. And not only has it taught me a lot about how Internet Explorer works, it's taught me a lot about Chrome and Firefox and Safari, because these guys know engineers on those teams, and they've introduced us to a lot of those guys through different things. A year and a half ago, I released a book called High Performance Single Page Web Applications. Like I said, I like to focus on single page applications. I've been building them probably since about 2009, and I've got, I don't know, 50 or 60 under my belt, right? As many as 400 views and down to 4 or 5 views. It just varies. I worked with a startup this past fall part-time. Probably spent about 75 hours total and launched a 75 view spa. And I'll kind of reference some of the little concepts that go into building these applications, some of the things we're going to cover today. So anyway, it's up there. It's getting a little dated. The demo site is not necessarily working the way it should because the API that I used is a public API that has sort of become deprecated. It's a movie application, and they took away the movie posters, so it sort of sucks now. So I'm actually working on a brand new demo and trying to get that together. Hopefully I'll have that up in the next couple of weeks because I'm going to be really going through it a lot at Velocity at the end of May. So if you want the slide deck, I did upload this slide deck this morning to SlideShare. I have 30 or maybe 40 slide decks up on SlideShare from the years. That's a kind of an ugly shortened URL that's not really shortened that much, but if you go to slideshare.com/DOCLUV, that's where all my slide decks are. Usually on sites like that, Doc Love is the moniker that I use. That goes all the way back to high school as a nickname. So, and GitHub, like you see up there, it's GitHub/DOCLUV. And that's usually where you can find a lot of stuff. The source code for the book and a lot of other repos are sitting up there if you want to browse through it. All right, we've all seen this, right? A loading thing, right? We all love when we see these things. Or when we're sitting there waiting on a site and we don't see this, it's even worse, isn't it? How many of you have been in a situation like that? Everybody should raise their hand right now. I know that. How many of you have built applications where this is something that happens all the time? Yeah. I've been there too. It's been very frustrating for me as a user. It's been very frustrating for me as a developer, especially going into teams where their application is really slow. For example, 2 years ago, I went into a company in Southern California, and they had one application they wanted me to help them fix. The average load time, this is a line of business application. The average load time when an employee logged in the morning was 13.5 minutes. No joke. 4,500 people a day logged into this application 6 days a week. The load time range was 2.5 minutes to 75 minutes before the person could actually start working, with the 13.5 being the average. There were so many things wrong with it. They gave us 3 weeks to figure out how to fix it. It was a really poorly written code base. We did get it down to about 2 minutes. It probably would have been more worth their time to have us spend about 2 months just to rewrite the entire application. That would have saved a lot more money, I think. But I point this out because web performance optimization can be really solving an annoying problem, sitting there waiting. And there's a lot of issues that we have with sites being slow. And there's a perception that the web is really slow. Now, when I build an application I have full control over, it usually loads in under a second over broadband, and it responds quickly to people's requests and actions on it. Now, we've got some great advice here from a great technologist, Will Ferrell, that I want everybody to consider. Before you get married, see how that person acts with a really slow website, and you'll see what their true character really is. All right. All right, so what is web performance optimization? Well, basically, you got to monitor, you got to test your applications, you got to figure out what needs to be fixed. There's a saying out there, you can't fix what you can't measure, and I think that's really true. So we've got to have ways to kind of figure out what exactly is causing the problem. Do we have the right metrics? Are we measuring the right thing? Who thinks page load time is the right metric to measure? Wow, nobody raised their hand. You know, that's usually the go-to. How long did it take to load? The real question is, how long did it take to render is the startup thing. You got to think about it. Every time we go to a website or a web page or web application, we are installing that site. Just as if we went to an app store and installed the application, we have to install the website to get it to run. And so we have to make sure that that process is streamlined as much as possible. And even after it's installed, what is the interaction like after that point? Can we make it almost instantaneous? Can we make it feel like the user is really ingrained in the application and doesn't have that cognitive load increase or that disconnect where they've done something and the reaction that they're expecting doesn't happen? So there's all kinds of metrics that we need to figure out how to measure. Now, other points. Who knows who Matt Cutts is? Hey, a few hands, not many. That's kind of normal. It's kind of funny to me when I talk to web developers that no one really seems to know who Matt Cutts is. Now, if you talk to a marketing crowd, most of those people are going to know who Matt Cutts is. Matt Cutts is basically the the Scott Hanselman of Google's SEO division. If you want to know how to rank or how Google ranks you for search engine optimization, you need to follow what Matt Cutts says, because what he says is gospel. If you violate what he says, your site will get blacklisted. That's basically the rule of thumb. So he had this quote a while back about web performance. It says, take a step back for a minute, consider the intent of change. A faster web is great for everyone, but especially users. Lots of websites have demonstrated that speeding up user experience results in more usage. So speeding up your website isn't just something that can affect your search engine rankings, it's a fantastic idea for users. Web performance, or page load time, is actually a key factor in search engine placement in Google and Bing. And they do it because what they're trying to do is find the sites or the source, the resources for those search results that give the user the best experience, give them exactly what they want. And if the users are going and coming back, they immediately know that that site's probably not the right site to send people to. And they want more traffic on their search engines because that's how they drive revenue through ads on those page views. So faster sites rank higher, and that's primarily because faster is a better user experience. Now, here lately, as of the 21st, April 21st, I believe, if your site is not mobile friendly, basically if your site's not responsive, you've got another ding against you in search engine optimization. I think the number is 60 or 69% of searches on Google now come from a mobile class device. That means either a phone or a tablet. And that's a big deal. I was watching CNBC this morning while I was getting ready, and they were interviewing different CEOs. It's out the Warren Buffett thing, and I can't remember which one it was. I think it was like a party store or something like that. Anyway, they said that the CEO said that 60 to 70% of the traffic to their website now came from mobile devices, and their revenue from mobile was up 160% over the last year. That's a huge deal. If your site is not geared to respond to those mobile devices and respond quickly, you're losing a lot of opportunity. Now, if you're in the enterprise and you think, oh, we're not mobile, wrong. You are mobile, whether you believe it or not. And I'm going to go back to that same place in California because this is the classic example. I'm sitting in a conference room with a manager. She had 1,500 developers working underneath her. And she said, yeah, our company's not mobile. Now, the conference room we were in had those glass walls. And on the other side of those glass walls was a cube farm with about 150 of her developers. And they had short cube walls, and I had been walking around. And I could literally look over her shoulder and count about 15 mobile devices that people were using at their desk, her developers. Of course, the company's not mobile. Your business people are mobile, whether your IT department admits it or not. You've got to make this stuff work. Time is money. Now, I've referenced a little bit about search engine optimization, users recognition, but there's been lots and lots of studies. These are just a few. I could probably reference 100 of them, be honest with you, of sites that have made direct correlations to performance optimization to their bottom line. Higher conversion rates, more sales, more traffic, longer session times, repeat customers, higher brand, I think it's brand recognition is the right thing. Basically, you have a better opinion of the companies. I was out at Velocity last year, which is a web performance optimization conference. And Tammy Everts, which she does a lot of research on usability and stuff like that. She actually had measured brain activity, positive and negative brain activity for customers booking flights on airlines in Europe. And the slower the site, the less they thought of the airline. They already had a negative impression of that particular airline. The faster the site, the more positive impression of the airline. This all plays into your brand quality out in the public. Walmart, this is a few years back. They had a lot of pages that were taking 24 seconds to load. They did enough study to realize that they weren't making any money on those pages. They have changed a lot of policies on their site. They have a lot of third-party vendors actually injecting content into the site dynamically. They actually have an SLA in place. If you cannot meet their SLA, you're cut off. That means if you're not loading fast enough, you've got JavaScript errors, things like this, things that detract from user experience, they're cutting you off, and you're not going to get any traffic from Walmart.com. Google actually played with something. Right now, and they've been doing this for years, you get 10 results per page. Well, they thought, well, what if we add 30? Would that make more people come to our site? Well, it slowed the page down by a half a second, and they had a 20% drop in traffic to Google because of that. And so you have this quote here from somebody named Marissa, and she says, speed matters. Who knows who Marissa is? Somebody want to say it? She's now the CEO of Yahoo. That's right. So basically, people don't like to wait. Don't make them wait. So I love this slide. I share this slide in a lot of my presentations, even if it's not web performance optimization, because it's so important. 57% will abandon a site after 3 seconds. That's very key. There's been a lot of sites, and I've had some Twitter battles with some of my MVP friends about performance. And there's like some e-commerce sites that I've tracked, 8 to 10 to 12 seconds per page load, and they were like, it doesn't matter. People are still going to buy whatever it is, and that's completely false. The studies show that if you're not loaded within 3 seconds and cognitively there, people are going to your competitor or going back to the search result or whatever it is. We have to concentrate more for slow sites. That means we have to use our brain more. We have to stress. It's physical stress, mental stress that we have to use when our sites go slow. And surveys show that at least 78% of us have had a lot of anger with slow sites. Does that make sense? And 44% say slow sites make them anxious. Again, even if you're in the enterprise, this comes into play with line of business applications. I was at it's not the DMV in Pennsylvania, but they have like private vendors that do it. And so I was getting my license plate when I moved up there for my car. And it took like 25 minutes for the lady to go through the system. And I was kind of talking to her, and she goes, yeah, every time I hit a key, I have to sit here and wait for something else to happen, wait and wait. And it's sometimes 2 and 3 minutes between transactions. That's a poorly designed system. I did the math. I figured that was cutting out like 3 hours of her day just sitting there waiting for this if she did nothing but do license plate applications all day long. And this is my favorite stat. 4% of people admit they've actually thrown their phone waiting on a site to load. So I'm just kind of surveying the crowd. There's got to be at least 1, possibly 2 people in here who have thrown their phone, right? Yep, they're okay. You admitted it. Thank you for finally admitting it. Believe it or not, I think it's Sweden every year has some sort of contest or festival or something where people get to throw their phone up against the wall and release their frustration about mobile. There's a couple of videos on YouTube. It's hilarious. All right. So we've got a problem. Websites are getting fat and out of shape. And there's a quote going around the internet that's absolutely right. We have created the web in our own image, obese. And I'm going to show you some stats about the web. And honestly, this played a little, kind of convicted me personally too, because I knew I had gained more weight than I wanted to. And back in December, I had to go to the doctor for a checkup, and I weighed in, I was 272, and I was like in shock. It was like 30 pounds more than I thought I weighed. So believe it or not, since the first of the year, I've dropped 70 pounds. And part of it is because I'm not here preaching about web performance optimization and making really small websites, yet I was overweight. I still am, but I've got some work to do. But yeah, 70 pounds in 108 days. So I want to apply that to web. These are some real stats. I went and updated them last night. I always update them before I do a presentation of the latest numbers. The average website today has 99 file requests, HTTP requests, which is a ridiculous number, and is over 2 megabytes in size. And I like to put this in perspective. In 1996, I wrote a master's thesis. It was 186 pages long in Word. It was approximately 300 kilobytes in size. That fit 5 times, or almost 5 times, on a 3.5-inch floppy, which was what we used for portable disk back then. We didn't have the cloud. We had SneakerNet. So think about it. The average web page today cannot fit on a 3.5-inch floppy disk. You would need 2 disks to put a web page on today. That's very unacceptable. Let's put this in perspective. The 75-view spa application that I built for that startup had 120 kilobytes of JavaScript, complete. React is 120 kilobytes of JavaScript, plus then you got Flux and all the other crap you put on top of it. Angular is 120 kilobytes. jQuery is right around 120 kilobytes. I built the entire application in 120 kilobytes. The CSS in the site, complete application, was like 20 kilobytes of CSS. If you use Bootstrap, it's like 600 kilobytes of CSS and JavaScript and stuff that you're including into that draw. That's a big deal. The average site has 18 JavaScript files. Yeah, you should strive for a JavaScript file, period. 318 kilobytes, again, I had 120 for a 75 view application. A view is a page. The entire application was 120. 6.4 CSS files, again, you should have one CSS file. 53 images at 1.3 megs, and obviously that's a big chunk of the data, and there's a big problem with images we have. They're usually not optimized. I was at a large e-commerce company most of this last year. The second half of last year, I spent most of my time at a very large e-commerce company. I want to say they had, let's just use the number, 10 million page views an hour. And I'd done analysis, some of the things I'm going to show you here in a second. And the images on their product detail page were about 40% larger than they needed to be. So I showed this to one of the main managers, and she got me in touch with the right people, and they then changed their CMS process to include an image optimization step in the upload and distribution to their CDN, which was Akamai and stuff. Think about that. Not only does the page load faster, but now their CDN hosting costs have been reduced by about 25 to 30%. And if you think about 10 million page views an hour times the number of images and stuff involved in that, that is a massive bottom line immediate impact right there. Not to mention, we did this right before Black Friday. That made their site work so much better on Black Friday. It was a big deal. And that was something simple. It didn't take them but a couple of hours to get this in place. 38 TCP connections. That means there's a lot of overhead opening up each one of these connections, which cause more delay. Across 17 different domains. That means there's 17 DNS lookups that has to occur. A DNS lookup has to happen on every single domain, even if it's a subdomain. And those can average between 80 to 300 to 400 milliseconds. You really should strive for closer to 50 to 100 milliseconds if you can. Personally, I use Route 53 on AWS, and that seems to be working fairly well. I think my average is somewhere around 90 milliseconds right now for a DNS resolution. And this is something else that's troubling. Only 46% of the web is using cacheable resources. That means they got headers set so that the browser can cache the content locally. And I see a lot of developers saying, oh, it's okay if I use 15 JavaScript files. They're all going to get cached by the browser. That's totally not true. If you actually do analysis, a lot of the stuff is not getting cached. A lot of the images are not getting cached. And on mobile devices, that browser cache gets purged a whole lot faster than it does on desktop. Now, at one point, and this isn't necessarily true anymore, when I first started doing these spas like 5 and 6 years ago, the iPhone, if the resource or the file that was requested was over 25 kilobytes, it was not cached at all on the phone. So that meant every time that you loaded a page, everything had to get downloaded all over again. And that's a really bad scenario. You definitely don't want that over mobile, because mobile is expensive bandwidth-wise in a lot of ways. So here's the latest chart, and this chart comes from HTTP Archive. That's where all these stats came from. And HTTP Archive is run by Steve Souders, and I call him the godfather of web performance optimization. He released a book, I think back in 2007, and it really changed the way I build websites at the time. He came out with 16 YSlow rules. Those have been expanded to 23. We'll look at those here in a second. But he keeps this running thing. And what he does is he runs several 100,000 URLs through a tool that I'm going to show you here in a minute. And he gets all these stats. And he publishes these stats twice a month and keeps updating them. So he's got a total here. And so you can see what the typical sites look like. So transfer size and request. That top line is the number of megabytes or kilobytes. So we can say we're at 2,061. This was stuff that was published last night. So this is the first of the month run. And then the 99 different HTTP requests. There's a lot of other stats. He breaks it down by different file types and so forth. Like I said, mobile accounts for most of e-commerce traffic these days. You can see the breakdown between tablets and phones. It's kind of interesting to me that smartphones are such a big chunk of it compared to tablets. Because I spend more time on tablets than I do phones personally. But I work at home most of the time. So, you know, my tablet and my Surface and stuff like that are my primary devices. My phone's primarily a music machine for me. So, but when I'm out and about like I am right now, I spend a lot more time on my phone, so I kind of understand it. And like I said, you know, you work in the enterprise, and so a lot of people in the enterprise tend to think that web performance doesn't matter, and it really, really does. You don't really want to waste your company money, because if your company's more profitable, it'll stay in business longer, which means you have more job security. And do you really want to make your coworkers hate you because you built a really crappy application that they have to use to get their job done? I really doubt it. And then they might throw a phone at you. And there's psychological stats. I'll kind of show you just a little bit of that here in a second. But think about that whole abandon the site in less than 3 seconds. There's psychological reasons why that happens. As far as data entry, slow sites have higher data entry rates, and that's because there's extra cognitive load. Hey guys, there's actually a lot of seats in here if you want to come sit down. I don't want you to have to stand up the whole time. And again, you are going mobile if you haven't already. Even if your IT department doesn't admit it, you've gone mobile. You need to design for that concept. Basically, this breaks down kind of how the brain works. Now, you have short-term, you have long-term memory, and stuff like that. So instant to the mind has to be in under 1,000 milliseconds. That's 1 second. Once you get past that 1 second threshold, the mind actually changes the way it thinks about what it's looking at and what's happening. And then at 10 seconds, it completely disconnects. And that's when people are already on Facebook looking at cat photos, all right? And so you got to kind of understand how the brain works. And you want to make it stay in that quick short-term memory, because the mind starts wandering after 1 second. And you don't want the brain to start wandering. You know, it's sort of like my 9-year-old, who's actually 10 today. It's her birthday. Anyway, she's like, you know, the complete distracted thing unless she's watching Netflix. I mean, it's over here, then here, then here, then here, then here, because it's hard for her to focus on stuff. But that's the reality of how the brain works. It's hard to stay focused on something. You may think you're focused on it, but you're already wandering off, especially if you're sitting there looking at that spinning disk or just a blank page. I also have a philosophy that good code is cheaper, and that web performance optimization creates good code, because you have well-structured code. It's a smaller code base, which means there's less opportunity for bugs. It's easier for maintenance. Yeah. And I also think it encourages development best practices. And we've got a lot of new stuff that's becoming mature for the front end now. And I also think it encourages discipline. I see, especially now, a lot of back-end developers are kind of being tossed into the front end. And I was listening to a Hanselman podcast yesterday, and he was talking to somebody like, yeah, everybody's a front-end developer now. And I really disagree with that. I think there's very few front-end developers, especially in the enterprise. I think there's a lot of back-end developers that are trying to figure this stuff out. And they're making a lot of mistakes. And it's mistakes that I made 5 and 6 years ago. So I'm trying to help people not make those same mistakes. So there's a lot of discipline that comes into understanding the front end. It's a different context than the back end. A lot of the patterns, a lot of the systems and stuff just don't translate that well. All right. So how do you figure out how to fix things out? Well, one of the things I mentioned is you've got to measure things. You got to know what is wrong. So for me, with my weight loss, I went out and bought a digital scale on January 7th and started logging my weight every single day. And as I progressed through the things, I started making more notes. I eventually got a band that tracked my calories. So I tracked calories for workouts and daily, started correlating to that, my sleep, all kinds of stuff. And that's why I was able to lose the weight so fast, is because I started understanding the data about what was going on around me. So you want to measure things like load time, obviously, but that also includes render time. And then there's a term called page speed index, and this is something that Pat Meehan created. He created this tool called Web Page Test that we're going to look at. And a big value in there that I'll look at on sites is this page speed index. And basically, it's the area under the curve. It's the integral of the rendering. How much of the page is actually rendered at certain times across the loading timeline. And you want to have something under 1,000. And if you've got something that's in the 10,000 range, you've got a lot of work to do. Like I said, rendering, runtime performance. I tend to look a lot more at synthetic tools like Web Page Test or just the F12 tools going into the waterfall. Those aren't necessarily what we call real user measurements. There are other tools out there for what we call real user measurements. I'm not going to get into those today because I think there's still so much work to do to get developers to get the load stuff fixed that we can get to the runtime after we finally get the load stuff fixed. But we want to try to get some of that real user measurement if you can. So we have like things like beacons and things like that that can report back. There's actually an API in all the browsers now for performance. It gives you all kinds of data about different points. You can actually set in your JavaScript code triggering certain points to get logged with this API. There's a lot of great information you can log and get. There's also a new concept that's become really popular in the performance world, and it's called setting a performance budget. So one of the things I had to do for my weight loss was set a calorie budget, both to burn each day, a number of steps to walk each day, and also calories to consume each day, and the kind of calories that I consumed. I actually cut out everything that had any kind of real fat in it. I cut out carbohydrates for the most part, and stuck to a fruit, vegetable, and lean protein kind of diet, right? So that was part of my budget. My calories, I set, literally, believe it or not, 4,000 calories a day. Several days I got up over 5,000. All these kind of things. That kind of concepts translate to our web as well. Tim Kadlec is the one who created the concept of a performance budget. And you can read a little bit about it, but basically it's identifying some factors like load time, page weight, things like that you're going to say, this is what our budget is. If we go over this budget, we got to trim it down some way, one way or another. And typical load times, a lot of places say they want to shoot for under 2 seconds. I think that's ambitious for a lot of places since the average times are usually around 8 to 10 seconds from what I audit. My personal standard when I build stuff, like I said, is under a second over broadband. But yeah, I think it's very important that you set standards for mobile and cellular towers as well. It's a completely different ballgame with those guys. So a lot of times I say like 4 to 5 seconds over a cell network. And I encourage people to benchmark against something like Sprint 3G because it's the worst possible you can get in the United States. It is so freaking slow. So back in 2010 when I built my first what I call really big spa, we had 400 views in the sucker. And I was on Sprint 3G with my self plan at the time. And it would take 30 to 45 seconds for the home page to load consistently. And I remember I was actually at a Phillies ball game, and the lady sitting next to me was talking to me before the game started, talking about what I did. And it turned out she was very interested in the product that I was building. So I tried to bring it up on the phone, and I could tell she was not impressed because it took a minute to load in the ballpark. And that weighed heavily on me. And I actually came back and started spending even more effort trying to figure out how to optimize the performance of this application because it had grown so fast and gotten huge. So there's a lot of pieces when I build spas that come from that experience. So definitely want to try to shoot for load times, but also the page weight. Now Tim also has recently created something where it's a website. It'll tell you what your page costs to load over published cellular data plans in different countries. We're going to look at that here in a second. I think this is very key. Another thing to set a performance budget is HTTP chattiness. I'm kicking myself because I can't recall the reference to a research paper that I read a couple of years ago, but they actually audited native applications on mobile devices, and they determined that 96% of the calls to the API, which is AJAX calls, were for duplicate data. In other words, they didn't need to make that AJAX call. That's a very chatty application, and it also makes the application run slow when it has to make those calls out across the web. And the same holds true for web stuff too. I sit there and watch the same thing on websites. I sit there and just watch the waterfall continue to grow after the page is loaded. So I mentioned Pat Meehan and Web Page Test. I use this site all the time, and it's a great synthetic testing tool. It is a public website, so your site has to be public. You can stand up a private instance internally. He's got VMs that are available. In fact, on AWS, it is a VM that is already prepared. All you got to do is say, I want to use the web page test VM, and it'll spin it right up for you. I've been chatting a little bit back and forth with Pat over the last couple of months about getting one in Azure. It's getting close to being ready. So it'll make it extremely easy to set up one based in the cloud, and you can set it up within your internal cloud kind of confines or whatever, so that you can get to your behind the firewall applications as well. When you run it, you get a nice little scorecard over some things, and obviously it kind of gives you a quick insight of what's good and bad about your site. I also like that it gives you a really detailed waterfall. Who knows what a waterfall is for a website? Okay, basically it's how all the resources for your website loaded. And we call it a waterfall because it kind of well, I'll look at it this way. It tracks kind of that way. You want it to track like this, be as straight as possible and be as short as possible as well. This is kind of a clip of one right here. And then another key piece of information that I like is this web page view. I actually did this on the, I think this is the Cleveland paper, the sports section. It didn't start rendering until 2 seconds, but I'm going to look at the Columbus dispatch here, real time, not real time, but I ran some tests this morning I want to show you. All right, so let's do that real quick. All right, so this is web page test, and all you got to do is just drop your URL in there, select what browser you want. Another great thing about web page test is he's got instances set up all over the world. So if you need to see how fast your site loads in Sydney, for example, they've got a data center set up in Sydney. Now, not all the browsers are set up on every single location. So if you change, this is Dulles, which is where you created it. So if I went down to, say, Buenos Aires, we'll have a few less. We only have the 4 main browsers, or 3 with Canary. A couple of them have some mobile phones set up, things like that, so you can see what it's like over a cellular connection. It's very good. It also has an API, so you can programmatically run these things without even coming to the website. That's a test result. So this morning I ran some tests. I like to run newspaper sites through here because they're horrible. They're just terrible. I don't even know why anybody bothers reading newspaper sites, except that I like to read the sports. I actually follow the Texas Rangers, and I'm not ashamed to admit it. Anyway, so I ran the Cleveland, the Cincinnati, and the Columbus sports pages through here. Let's go look at the dispatch. So it got 3 Fs, and it couldn't determine if the CDN was even used, which is not a good sign. It did get A's on Keep Alive, and it got an A on that. It got a high B on compressing. That's G-zipping. You definitely got to do G-zipping. And then it got a really poor time to first byte. Now, time to first byte usually indicates that there's some server-side issues about rendering it. Something like the sports page of the newspaper, like the dispatch, should be something output cached. If you've done ASP.NET, you know what I'm talking about. It should be cached somewhere so that there's no server-side rendering process that really needs to get executed. So we can look at the waterfall for this, and you can see that it took about 13 seconds for the first byte to even come through on this particular test. That's ridiculous, right? But here's the rest of the waterfall. Oh, by the way, the red, that means that your resource couldn't be found. It's a 404. Look at all the requests. This is bad. Real bad. Still going. Oh, there we go. Okay. Yeah, it's really bad. Now, I want you to notice at the top there's a little scorecard, just some stats. Usually there's 2 runs done. Because this one took so long, I think it only did 1. Okay, I'm not joking. I think it's set up to just do 1 if it's really long. Now, let me span this out a little bit. Okay, so you can see that the load time was over 21 seconds. Time to first byte was 13 and a half. It didn't even start rendering until after 15 seconds. It has a 20,337 page speed index score. That's really, really bad. Actually, not too bad on the DOM element. It's only just over 2,000. That's another common error that I see is just something like divitis. That causes the browser to get sluggish the more you have. Let's see, 198 requests. The fully loaded request is 711 assets. And it was over almost 8.5 megabytes total. And what does it cost to load? So they've got a link straight over to that, what does it cost my site to load? If you were in Vanuatu and you wanted to see what was going on in the Columbus sports area, it would cost you $2.71 to download the sports page of the Columbus Dispatch. So my advice is not to go to Vanuatu and load the Columbus Dispatch. In the US, over cellular, you're looking at 61 cents, but you can see kind of how it goes down. The cheapest place is Sri Lanka at 3 cents. Why is Sri Lanka cheaper than here to download the Columbus Dispatch? We'll never know. Anyway, let's go look at the video. So here's the film strip view. And I love showing this to clients. All right, there we go. Let's expand that out a little bit. Notice 15.5 seconds is when I got the first stuff rendered. Now if I go back just one, this is screenshots of the page as it's loading. So at 14.5 and 15 seconds, it's a blank page. You do not want that. You want that first one to be less than a second, trust me. So let's go back. Let's just look at my blog. There we go. So this is my blog. That's my waterfall. Most of those are the images for the tiles that I've got have loaded. Also notice the second one there. There's hardly any request at all. Basically, I think it's the Google Analytics. And at 1 second, it started getting rendered. And that's what you want to see. Honestly, I'm not happy that it was 1 second. I want it to be like 7.5 seconds, but that's okay. I'm actually going to be rebuilding it in the near future. Hopefully in the next few weeks. Try to make it a vNext application. Let me just kind of go through the waterfall real quick, because I want to show some interesting pieces to it. That kind of dark teal, that's DNS resolution. That's the computer having to figure out where the site's located based on the domain. So it has to go through the whole DNS system to ask what the IP address is. The orange is it creating the connection. So it's basically opening up the connection, getting the overhead in place and stuff like that. And then the green is what it waited on the server to return the content from the server. And the blue there is kind of it finalizing, basically coming across the wire. So everything came within 400 milliseconds there. Now, you can see there's other things here. So I've got all my images on a CDN. So I had another CDN, DNS resolution there. And then I actually borrowing an image from Carl Franklin off his PLOP server, so his DNS resolution. And then another one off of Xbox. This is the one you're seeing with the purple. That's the little Spartan logo that I got up there. So, I'm not compressing the transfer. Oh, I think it's because my JavaScript or something is not compressed right. And I've got a couple of images that I'm borrowing that are not compressed. So, anyway, you can see, according to this run, I've got a little work to do, and that's good. I'll fix it eventually in the next week or so. When I first launched this particular version of my site 2 years ago, had a lot better scores. The data is coming in. We're getting a lot more detail about data we need to do. Are any questions about web page tests? There's I've got a whole presentation and more that I could talk about it. So, all right, well, let's move on. Yeah, it's a great tool. It's free, and I advise everybody who wants to understand how websites work, go use it because you'll get a lot more insight into what's going on. So, I mentioned Steve Souders and his YSlow Rules. All right. It's not you, it's me. Let's see. Duplicate. PowerPoint playing with me. Okay. Now it's up to 23 rules. If you remember Firebug and Firefox, they created a plugin called YSlow. It basically would analyze your site. And these are kind of published rules. These should be things that every web developer lives by. But the reason why I have to show this is because even after 7 or 8 years, we're still not applying these rules to our web development process. Case in point, the dispatch waterfall. When I look at these waterfalls on these sites, I know these things are not being applied. When I go into clients and they have me analyze their site, I can produce 50 and 60 page reports that are basically repeats of the previous one I went to because none of the stuff's being applied correctly. All these things are very easy to accomplish. I'm going to cover 10 things that are kind of what I call low-hanging fruits that you can go do. The first one, add a fav icon. How many make sure you have a fav icon on your sites? Please do that. It's actually part of the File New project in Visual Studio for a website. They give you a stock one. Always make one with your brand on there. I'm amazed at how many sites still don't have fav icons. Now, I love this quote. Most of your scaling problems won't be glamorous, by Mike Krieger. Who is Mike Krieger? Anybody have a clue? Well, he found out something really big when he launched his application. Anybody recognize that icon? It's Instagram. Their servers crashed because they didn't have a fav icon on their website. And the reason is because every time you request something, remember on the dispatch there was like 5 or 6 404s? That means the browser is asking the web server to return a resource. The server says, I can't find it. And then the next person comes along and says, I want that resource. The web server says, I haven't found it yet. Let me go see if it's there yet. And what happens is it keeps reaching the disk, and you have disk I/O. And if you've got 35,000 people a minute trying to sign up for your service, you have a lot of requests coming in for your fav icon, and you cause disk thrashing, which causes your server to become unresponsive. And thus your site crashes. So you want to make sure you've got no 404s, and the fav icon is a common thing that people forget. Next is use a CDN. I've had my images and some other assets up in Amazon's S3 for the last 5 or 6 years. Back when this was part of the original YSlow rules, the only real CDN available was Akamai, and it was super duper expensive. So at the time I set up what I called a poor man CDN. I set up a subdomain on my web server and put my images there, and that was the best I could do. Now I spend 16 cents a month serving the images for my blog, and it's super cheap, and it's super easy. And Azure now has a CDN service as well. You just upload your stuff to your blob and map it over, and you're good to go. But like I said, pennies a month for the typical website. If you're that e-commerce site with 10 million an hour, a little different cost factor, but you've also got a lot of revenue coming in to cover it. But anyway, nice and cheap. Another way to reduce the amount of requests to your server. Now remember, every time you reduce a request to your server, that means the server scales more. It also means you don't have to use as many servers, okay? Set a far future expires header on all resources you possibly can. And basically what that means is you're telling the browser, hey, this asset, it's good for the next year or two. Don't bother coming back unless, we really have to. At that point, you can cache bust and stuff like that if you need to. But that eliminates a lot of requests that you don't need to worry about. And, it's better all around. So your server runs better and your client runs better. Another way to cache that I have developed over the last few years is leveraging local storage. And a lot of people wonder why I use local storage as much as I do. It's not that big of storage space. It's only like 5 megs, but I'll be quite honest. I cache my entire web application in there, all the markup. I'm starting to cache the JavaScript and CSS in there, and I'm caching all the data and setting timeouts and stuff like that for staleness. So the way it works, it's a string-based hash table that you get to store stuff in. Most browsers, it's 5 megs. Older Android devices, it can vary between a meg to 3, 4, 5. It just depends. I've never had a problem reaching the quota with any of the applications. Even a 400-page SPA, I had room left over, lots of room. You have 2 flavors, local storage and session storage. So just like ASP.NET has session cache and application cache on the server side, the same thing comes into play in the browser as well. So if session storage, the only difference is once the person kills the session or closes the browser, all the data is purged and it's not around. So if you've got some semi-sensitive data, that's probably where you want to purge it or store it. Like I said, you get 5 up to 10 megabytes if you really know how to do it right. It's a great way to replace cookies. We'll talk about cookies here in a second. And I use it for caching. And if I need a lot more data, then I'll move over to IndexedDB. IndexedDB is like MongoLite in the browser. I think you get 50 megs in there. I've seen some studies where I think the Financial Times in London showed how they could get up to 500 megs into IndexedDB. I've very rarely even had to even look at it, to be honest with you. Like I said, I use AJAX caching. I check local storage before I make an AJAX call. And if it's in local storage and it's not stale, I'm just going to pull it out of local storage rather than make that call across the web. Like I said, I put an expiration or time to live value associated with whatever data it is. And it's amazing how much that reduces my HTTP requests. Remember I said 96% of AJAX requests from applications are for redundant data. Mine have none, really. Which radically improves performance because when I go to load a page, the data's usually there and it just pops right up and it just loads. And remember, the fastest AJAX request you can make is the one that's never made, right? So if you've got the data essentially in memory, you don't have to make the request and it's instantaneous. So try to avoid using cookies anymore. Cookies are bad. They add weight to all of your HTTP requests, and this is something a lot of people don't understand or realize. We'll look at some stats that Yahoo did a few years ago to kind of show how it plays in. You want to place all your static resources like images and text files like CSS and JavaScript on some cookieless domain. That's why we put them on a subdomain on a CDN. You don't need to have like the authentication cookie piece going back and forth. Again, consider local storage for stuff. That way, the customer's settings and stuff like that don't travel back and forth constantly to the server. You don't have to do that. You can just put them in local storage, and they're there. You can send them down to the server one time and persist them with their server-side profile, and then make that go up to other devices and whatnot, depending on your application. So if we look at kind of what the cookie looks like in a request detail, this is from Southwest Airlines. I usually pick on their site a lot. So this is for a JavaScript file. And you can see that there's a big cookie that's coming along, riding with the request, because cookies ride on every single request to whatever server or whatever domain that cookie originated from. So you want to try to avoid that. This JavaScript file does not need a cookie going back and forth with it. These are stats from Yahoo. They did, I don't know, 10,000 or 100,000 requests with cookies of different size on essentially an empty piece of data to see what the effect of a cookie had on a particular request. So the baseline with no cookie and basically an empty string being returned was 78 milliseconds. And then when they added a 500 byte cookie plus 1 milliseconds, but when you go down to like 3K, it's an additional 78 milliseconds. And 3K is, you know, that sounds like a lot, but I've looked at a lot of cookies. A lot of cookies are a heck of a lot bigger than that. So basically for 3K, you've doubled the amount of time for a basic request to come back from the server. This was because there's more weight. And if you think about it, the way HTTP is packaged plays an effect. Another thing that we're trying to strive for in the web performance optimization world is stuffing as much as we can 14 kilobytes of content, because HTTP packets start off at 16 kilobytes, with 2 kilobytes of that being overhead or headers, and then the rest of the 14 is actual data. So you want to try to eliminate as much as you can so you have a small packet that only requires one bucket to come back over that HTTP request. So remember, well, 95 files, but let's say 99 files. If all 99 files had 3K hit, you can see that now for just 95 of them, that's an extra 1.25 seconds. Of course, each browser connection to a domain usually gets 6 parallel downloads, so it wouldn't quite be that much of an impact, but still that's 1.2 seconds right there, just in cookie overhead. And it does cause a delay. Like I said, parallel downloads will help. And again, don't use 95 files or 99 files. Images. Images obviously are the biggest payload weight for most sites. But like I said, most images are not optimized. If you run them through an optimization tool, like PNG Crush or Image Opt-in, there's an online service that I use called kraken.io that costs $10 a month, and it actually has an API that you can run through. In fact, the other night, for the fake data I was setting up for the new application, the demo application I was working on, I was running all my images through it using Node, believe it or not. Just wrote a little quick Node module, and it just sat there and looped. Because I got 5,500 images for this site that I'm building. And what it did was it just optimized all of them. Another thing is image sprites. So if you've got a lot of little tiny images, consider putting those together into a single image and using image sprites. Who knows what an image sprite is? Okay, good, most of you. Basically what it is, it's leveraging CSS background image, and then you set basically the viewport on that particular big image of what's going to get displayed. Glyph fonts, things like, what's the one that Twitter Bootstrap uses? Font Awesome and stuff like that, yeah. You can find all kinds of fonts that can serve as like icons and things like that on your application. That can be a lot more effective because they scale better. Also, if you use SVG, that also can scale better, and those can also be smaller. A lot of times you have to kind of play with what's best. Do I use a data URL, which is a base 64 encoded string, or do I use an image sprite? Honestly, there's no true answer. You're going to have to play with your images and kind of tweak and find what works best for you. This is an example in the South. This used to be the Southwest header. Each one of those things that I have circled up there were individual icon files. They could easily combine those into a single sprite and make that one request instead of 4 requests. Also, the image file itself wouldn't be that much bigger for all 4 of them because there's header content and stuff like that involved for each file. There we go. This is another thing that should be just common knowledge. Bundle and minify your JavaScript in CSS, but I never see anybody do it. I do see some places that minify stuff, but then they still have 40 JavaScript file requests, and only half of them are minimized, and half of them aren't even compressed. This radically reduces your data footprint. It also reduces the number of requests you have. Remember, what was it, 17 or 19 JavaScript files? It should be 1. And it's very interesting. I had an argument with somebody on a team that I was working with a few weeks back. And he's like, well, you don't know what it's like inside whatever shop it is. Because we weren't even talking about their application. We were talking about somebody else. And I was like, that doesn't really matter. It's not the point I'm trying to make. The point I'm trying to make is that they could make their application work a lot better if they would bundle and minify. And I was showing him how they didn't minify even a lot of this stuff. And he just didn't like it. He's like, well, you don't know what the culture's like. I'm like, well, they need to change their culture. And that's the reality. I think a lot of development shops need to change their culture. And this is a big piece of it. If you've got 25 JavaScript files being requested, you need to bundle and minify. You need to look at that process because it's not that hard to do. Another thing, a little kind of side note, inline critical CSS and removed unused CSS. This is something new that I'm doing. Basically what you've got to try to do is, for my spas, my core layout of my application, I'm running it through a tool called UnCSS. It's a little node module that Adi Asamadi created. And there's a grunt module. I think there's a gulp module for it as well. And basically what it outputs is these are the only rules that are used for this particular page. And what I do is I give it a page with just my core layout, none of the content of my application. And what I'm doing is I'm then injecting that output CSS into my header as an inline thing. It's usually not that big. It usually only adds another 3 or 4K before it's minimized and compressed to my initial markup payload, which means I'm still getting to that 14 kilobyte size. But because my CSS is there, it renders instantly. And so like when you're seeing like my blog, say 1 second before it starts rendering, that's going to be fixed in the next few weeks because I'm going to do this little trick with it, and it's going to start rendering a whole lot faster because that initial payload is going to come down in less than a half second and automatically get rendered. Then I'm going to request the other CSS and the JavaScript, and the application is going to basically hydrate itself at that point. But I've got my header and some navigation pieces and initial background colors and stuff like that are starting to blend in. So the mind perceives the site as loaded or loading, and it makes them feel better. The other thing too, like if you're using Bootstrap, I guarantee you're probably using less than 10% of Bootstrap. And this is the the key thing that Adi shows with his tool is he runs a typical Bootstrap file, site through the UnCSS and points out that like 6% is being used. And it creates the CSS that is actually being used on a particular page. The one drawback to this is if you've got like stuff that's dynamic, meaning like I hover over something or I click a button and I add a class to an element or things like that, you kind of got to watch it. I've learned to put those things into separate files that aren't considered, and that way they get included and whatnot. So I encourage you to go like to Node, to NPM. So try to play with this UnCSS module. You'll be surprised what you find out about your sites. Use a client build system. How many of you have used Grunt or Gulp? This is what is shipping with Visual Studio now. They've actually deprecated the server-side clamped-in C# bundle and minifying stuff, and now they're moving it to Grunt and Gulp. They're shipping Node with these modules already running inside of Visual Studio, and they've got some great tools to make it so you don't have to go to the command line, which is awesome. But there's all kinds of plugins for these task runners. I call them compilers. They like to call themselves task runners. I call them web compilers. And I started using them for bundling minification, and now I'm using them for lots and lots of other stuff. If you're, like, say, doing Node, you can actually create a Grunt or Gulp script that automatically fires up and will execute your web server for you, do live reloads, watch files, automatically run lists, and all that kind of stuff for you. So there's all kinds of amazing stuff you can do. Broccoli is another one out there. There's 3 or 4 others that I've seen. But I encourage you to, if you're not using one of these build systems, please do. This is kind of a real quick compressed version of a Grunt file. What you have to do, what you do is you set up a JSON object with all the configurations and it runs over it. Gulp uses JavaScript syntax, basically promise notation and stuff like that. So it kind of comes at a different angle. They both accomplish the same exact things. I think Grunt has a much bigger ecosystem available to it at this point, though. Another common thing that I see people missing is gzipping text content. That's another big no-no. Remember, trying to get under 14 kilobytes. If you're not gzipping text, then you're kind of wasting bandwidth at that point. So, like I said, you want to try to get under that 14 kilobytes. That's kind of tough to do in a lot of cases, but it is possible. To set it up in IIS, you just go to the compression, and it's real quick. You can just turn it on. Basically, look for the little, I call it the Clippy icon because he looks just like Clippy in the IIS admin, and it's easy enough to set up. Now, if you're using, I use Amazon S3 for my CDN. I can actually pre-gzip static content, upload it in compressed format. All you got to do is set the header associated with that file, and it'll get served with the header. Because really what you're doing is you're telling the browser, this is compressed, so the browser knows how to decompress it. If you don't do it, the browser's going to get all kinds of ASCII trash rendered, and you don't want that. All right. Another one that should be obvious, but I never see followed anywhere I go. Make sure your CSS is included in the head and that your JavaScript is the last thing you load in the page. And the reason is because you want stuff to actually get rendered as quickly as possible. That's why you put the CSS up front. And you don't want to block anything because JavaScript, when it loads JavaScript, whether it's inline or it's a file that it has to load, that is a blocking process. So that means it stops everything and stops rendering until the JavaScript is evaluated and it figures out if it has to start all over the rendering process. And make sure that your JavaScript and CSS are external. Of course, I'm violating that with my inline CSS, but there's a special reason for that. I do have another block of inline JavaScript that I use, and that's to do what we call cutting the mustard, to determine if I need to go back to a core site, meaning that it's an old browser or it's a search engine spider. Now, when I'm talking about why you want to put the CSS at the top and the JavaScript at the bottom and external files and stuff like that. It's because of this critical rendering path. Who's seen the critical rendering path before? One person. You were the first person in one of these presentations that I've done to web developers that have heard of that. So congrats. If you're not a web developer and you're not familiar with the concept of a critical rendering path, you need to study this. This is how the browser works. And this is why I think it's really important for all these developers who are trying to come to the front end to understand the platform they're building in. The browser is your platform. This is the flow chart of how things get built. So first, it has to make the network request. It gets the HTML. The HTML has directives to download CSS and JavaScript, which it then goes and does. The HTML creates the DOM. When it gets the CSS, it's not the best showing here, but basically it combines that DOM with the CSS to create something called the CSS OM, which controls how the browser starts rendering it. Meanwhile, it loads the JavaScript. And then it starts putting this together into a render tree. Now, if the JavaScript has a document.write, it goes right back to the very front and starts all over again, because now it says the integrity of the DOM has been broken and I have to start all over again. There are other little tricks to this, like if you are putting the XUA compatible in there for Internet Explorer, make sure you do that with the HTTP header and not a meta tag. And if you are using the meta tag, make it one of the very first meta tags, because that causes the browser to have to recycle through the rendering path. The same thing goes for even the character set and some of these other directives that are headers. Make sure you have these as early as possible so that the rendering path doesn't get too deep before it has to back out. If you have ever loaded a page and it's there and then it flashes or flickers or hesitates, what's happening is it's going back through the rendering path, and it's so jarring of a hit that you can physically see it. A lot of times you don't see it. What you see instead is a blank page. So by optimizing your page and your content, your assets, and architecting it correctly, this rendering path is fast and fluid and does not have to recycle itself. And that's one of your main goals, is not going back through all this again. Now, when you get to the runtime stuff, you get over the things over here with this layout and paint, and then that gets into a lot deeper concepts of performance optimization. If you want to look up terms like jankiness and stuff like that, like jankfree.org, you can start learning a little bit more about runtime setup and what CSS stuff is there. All right, we're a little bit over. If you really want like a little bonus, start using app cache. Even if your application doesn't necessarily have to work offline, it does have the browser cache things more locally, and that way you have a little more control over stuff, which gives you a much faster load experience. So I think we're 3 minutes over, so I think I did pretty good to get about 90 minutes into a 60-minute session here. If you got any questions, I'll be around today. If you got any questions right now, feel free to ask, and I'll be up here. But thanks a lot, and I hope you enjoy the rest of the day here at Star Trek.